this lesson, we're going to be taking what we learned about intermolecular forces and seeing how that affects changes of state of matter. So just as a quick review, if you start with a solid and that solid becomes a liquid, that's known as melting. If that liquid becomes a solid, it's freezing. Okay? If a solid becomes a gas, like what happens with carbon dioxide with dry ice, that's called sublimation. So solid to a gas is sublimation, gas to a solid is deposition. Then if that gas becomes a liquid, it's condensation, while if a liquid becomes a gas, that's called vaporization. And what you should notice on the right-hand side, this is what's called the heating curve. So if you look at it, if you start at the very bottom, that solid is heating up to 0 degrees. Okay? Once it's at 0 degrees, it plateaus, and it plateaus because the solid is going from a solid to a liquid. In order to have a state change, what's actually happening is you are breaking the intermolecular forces, which we studied, that are holding those molecules together. So that's why the temperature does not change. Then, when you're at 0 on that far side as a liquid, then the temperature is going to increase if you put in more energy. The temperature is going to increase until you reach 100 degrees Celsius. Now this is for water, it's going to be different values for other compounds. Once you hit 100 degrees, then you plateau again, and that's because the liquid is becoming a gas. Now notice this plateau is much longer than that for melting, and the reason why, when you melt, you do break intermolecular forces. But when you go from a liquid to a gas, you have to break all of the attractions between molecules. So as a result, it takes a lot more energy for a substance to boil, to go from a liquid to a gas, to be vaporized, than for it to melt. And then once you're at the end of that and you're completely a gas, then the temperature of the gas can continue to increase. So that's a heating curve. So let's talk really quickly about melting and freezing. In order for a substance to melt, a solid to melt, heat must be put into the system. Okay? And so that makes it endothermic. The heat is going to be positive. For a liquid to become a solid, okay, heat is going to be released, and that happens with freezing. That's why heat is released when you have a freezer. That's why you have a fan under your fridge in order to release some of that heat, or else your fridge would get overheated because the process of going from a liquid to a solid releases heat. So let's talk about a term that helps us in order to determine the heat that's involved in this melting and freezing process, and that term is your heat of fusion. So the heat of fusion is the energy that must be added in order to convert 1 gram of solid to a liquid at the melting point. So we're going to use this value, which will always be given to you, in order to calculate heat that's involved when, for example, ice melts. Okay, so if I have 15 grams of ice, I'm going to convert this into joules by using my heat of fusion. So I'm going to put grams on bottom, joules up top. Then the heat of fusion is 334 joules for every 1 gram. And so I get the heat that's required, or heat that's absorbed, to be 5,180 joules. Okay? So let's look at this for your other state changes. Specifically, let's look at vaporization and condensation. Okay? In order to calculate the heat that is involved with the vaporization or condensation process, okay, we're going to be using this heating curve a little bit later on, so I just wanted to include it there for you to see what's happening. You're at that top plateau right there where boiling is happening. Let's actually calculate this. Well, we need to use the heat of vaporization for this, and so the heat of vaporization is the energy that must be added to convert 1 gram of liquid to a gas at your boiling point. And so it's nice, I like the heating curve because you can actually see these processes. That plateau at the very top, that is the heat of vaporization. So let's actually calculate the amount of heat that's needed to vaporize 33.8 grams of water. So if I'm given 33.8 grams of water, if you notice, your heat of vaporization is actually in kilojoules per mole. So I've got to first convert these grams into moles. So I'm going to put grams on bottom, moles up top. I'm going to put the molar mass of water on bottom. Now I'm in moles. Now I can use my heat of vaporization. So I'm going to put moles on bottom, kilojoules up top, and then I'm going to put the 40.7 over 1 mole. All right? So now what I get when I do that math, I get 76.3 kilojoules of heat is required to vaporize that water.